Yeah, good afternoon, everyone. Again, I'm Mark Jackels. I'm a Senior Director of Production Software at DreamWorks Animation. And here today to talk about how DreamWorks uses or orchestrates massive workloads in our feature film production. But first, I want to get into some definitions to make sure we're all on the same page as far as terminology. We have a batch queuing system. I think you guys are probably familiar with that. That's a workload scheduling system that allows you to schedule work to be done on a pool of compute resources. A pool of compute resources and a batch queuing system is what we in the FX and animation industry call a render farm. For those, I think, may have heard that before. It's basically just where all the movie making happens. A unit of work that runs through our render farm is we refer to as a job, and that's the piece that gets scheduled out to run on some compute. And then a render is an image that a job generates. Now, not all the jobs that go through a render farm are rendering images, but the bulk of it is, so we just call it a render farm, and everyone speaks of it that way. And then finally, our artists don't submit individual jobs. They submit a submission, which usually represents some portion of the film, like a shot, and they will have in their tool be able to submit that. That gets broken down into a bunch of jobs that then get scheduled out on the render farm. So with that, I do want to, I'll just remind everyone what DreamWorks does. I have our trailer for our latest film, which is The Wild Robot, and as you watch, I just ask, take a look while you're watching the imagery there. Just remember, everything in there is actually generated with a graphics application or simulation, and keep that in mind.
A number of Universal Dynamics robots were lost in a typhoon. Chance of recovery is unlikely.
You need to learn how things work on this island.
Hello!
Goslings in print on the first thing they see.
You're his mother now.
His chances aren't super good.
I will protect him. He's got to leave this island by fall.
It is more dangerous for him than anyone else. But he has a chance. If where his wings end, his heart can pay the balance.
Sometimes, to survive, we must become more than we were programmed to be.
You are ordered to return home.
I am already home, and I am a wild robot.
Yeah. Well, we're actually super proud of this movie. It looks amazing, and it's the combination of realism, and then we put the stylistic over it to make it look that awesome. So if you haven't seen it, I highly recommend it. So given what I said before, it's all simulations and graphics, we have a lot of processing to do to generate these imagery. So here's some numbers for a single film like The Wild Robot. An 85-minute film is roughly 128,000 frames, computer-generated, rendered frames. But over the life of a film, each frame is rendered many, many times as it goes through the process. So in total, that's about 40 million jobs that run through our render farm just to make one film. And if we're looking at core hours, that's like 140 million core hours, or if we're looking at hyper-threaded cores, which we have hyper-threading enabled, that's more like 240 million virtual core hours spent in the process of making one of these films. If we're looking at wall clock time, that's about 10 million hours of wall clock time, just jobs, someone watching going through the farm. All that is contributed by 500 plus artists across 20 some odd different departments that are all involved in the making of this film over the year and a half or so that it takes to make one of these. So that's a lot. Hopefully that sounds like a lot. It sounds like a lot to me. But we don't make one film at a time. We actually have 4 to 6 films in production, plus special projects and shorts at any one point in time. So that ends up in, when we're in full capacity, we're pushing more than 4 million jobs a week through our render farm. And these aren't just all more uniform jobs, they're very different, anywhere from 1 or 2 cores per job to 96 or more cores per job. And the memory footprint is also equally varies greatly, a gig or 2 for job, all the way up to 100 or more gigs per job to render the scenes that something like what we just saw. So to do that, we have a render farm. It's roughly 50,000 cores in capacity during the day, and then at night it bumps up to 90,000 cores as all the workstations come online and join the pool. That all ends up being between 1,000 compute hosts and 1,800 compute hosts during the course, between night and day. So hopefully that sounds like maybe that qualifies as a massive workload that we have to orchestrate. And how do we do that? Well, that's where the HTCondor comes in. So quickly, what is HTCondor? It's a workload management job queue. It was written in the University of Wisconsin in Madison. It was a part of a research project that then became a product on its own. In 2006, the Center for High Throughput Computing, not high performance computing, was created to oversee Condor and keep moving it forward. It's a full-featured batch queuing system, very scalable, and actually has the capability to federate multiple clusters together, so it gives you a lot of capability depending on how you're structured. And it's heavily used by research institutions, universities, and CERN here actually has one of the biggest Condor installations of them all. So that's kind of the space it lives in. We're actually the only feature or only animation VFX studio using it, so that makes us kind of unique in that situation. So why do we like Condor? Just real quick, open source is very important to us. It's such a critical piece of infrastructure, and we want to be in control of our own destiny there. So having the open source it gives us a lot of ability to tune it the way we need it. It's a very scalable architecture, so the scheduling services can scale independently, so you can scale it up and down the schedulers as your demand ebbs and flows. It's highly configurable, which is really critical to us, given some of the diversity of our workloads that you mentioned before. The small jobs with 1 core can fill up the farm and starve out the big jobs that need like 96 cores, or vice versa. If the 96 core jobs take over, then you don't have any room to get the small jobs through. Condor configurability lets us dial those numbers around and tune it, the scheduling, so that we can make pathways through the render farm for a variety of job requirements. It's another important thing for us is the fair share. That's since we have 4 to 6 films in production, each one gets an allocation, so we need to be able to make sure every show is getting their appropriate amount of the render farm. But then we don't want to wall them off from each other, because we want to, if the one show is not using it all, then we want the other show to be able to use as much as it can. So Condor really supports that with the hierarchical share structure that lets a show use as much as is available, and then will rebalance as another show ramps up their usage. So it really suits our purposes well there. It has an elastic compute pool, so that means like I mentioned, the desktops come in the nighttime, and then they go out in the daytime. So that kind of capability, that's all automated. We don't have to deal with that. And other cases where we need to pull resources out or add additional resources from other locations because of immediate demand, Condor really supports that well. And then another critical piece is dynamic host partitioning. So that's, think of a host. We have, some of our hosts are quite large, 300 plus cores and half a terabyte of RAM. We don't put one job on that host, right? That job will actually run at the same time multiple jobs. And Condor actually kind of fits them in there. Think of Tetris, right? You have different size and shape jobs, and Condor's trying to fill in all the space so the host is fully utilized. And part of that is supported by the dynamic host partitioning. So a job can land, take up 24 cores and a couple gigs of RAM, and Condor will see how much is left and fill in that space. And then finally, not finally, there's many more features in Condor, but the last one that's really important to us that I'll call out here is a dependency graph orchestration. So I mentioned submissions earlier. An artist will hit a submission that actually isn't just a flat number of jobs. There's actually a dependency graph there. And taking a quick look at that, here's an example. Like one job will be rendering the character, another job will be rendering the backgrounds, and another job will be rendering volumes or clouds or whatever that are happening. And then a composite job actually assembles all those different pieces into a single image, or a single image for each frame, and then all the frames actually then get processed by a chute that those get encoded into an actually movie clip that the artist can watch. So that looks something like this. Is a very simplified example, but you'll see the troll is the character, and then the environment and the background atmosphere environment get rendered separately and then get assembled in a compositing pass. And that's really important for our filmmaking process. And this is actually a very simplified example. Our dependency graphs actually look a lot more like this. So and Condor also supports this very well as far as how all these jobs interact and dependencies are released properly. Just on the background, our usage of Condor, we've been using it since 2011. It's contributed to some of these films here and many more. And we have a pretty developed ecosystem around it. So obviously the baseline, the foundation of it is HTCondor job scheduler. And then we leverage open source as heavily as possible in this. We have an eventually consistent fault-tolerant data architecture, so as the data moves through our system, it eventually gets consistent with each other, and then we have to be careful. We have to be able to account for network problems and things coming up and down because it's a pretty big infrastructure, and our system handles that pretty well. It's cloud ready, so it's web service based, and tools that can accommodate moving to running in a public cloud or a private cloud, and then we are very careful to separate the operational and analytics data so that our analytics processing doesn't impact the operation of our tool stack. And then the last thing I'll call out is our job resource prediction system. This is actually fairly unique, and we haven't found many others doing this, particularly in our industry. And what that is we're using ML models and actually statistical analysis to assess, as the jobs come into the queue, we can make a prediction about how much RAM and how much runtime each of these jobs will take. And then we use those as attributes to inform the scheduler where to best place these jobs. So if during this process, we can assess if a job is going to need 40 gigs or 20 gigs, and the scheduler can actually use that in that Tetris scheduling mechanism to fit jobs together to make sure we don't oversubscribe a host. On a render farm, going into swap is actually a very bad thing for the render jobs. So it's very important that we make sure that the hosts all stay within the jobs stay within their memory and keep the hosts from getting into trouble. And then the runtimes can be used if this Condor knows that these hosts, like the desktops, are going to fall off the farm at 8 a.m. and at 7 a.m. it's going to not schedule jobs that say they would need 2 hours to run on those so they don't have to get kicked off the machine. So this alone has actually been really instrumental in helping us make the maximum utilization of our render farm. Keeping, we have some stats on that later. If you a quick system overview, this is you don't have to write all that down. This is kind of the architecture. We're using a variety of databases. We're using Grafana and InfluxDB, Kafka, Kubernetes to schedule services. I actually have a list after that, but this is kind of how it's architected right now. The light blue is the Condor processes, and then we have a data cache that helps us not have to hit Condor to get all the status on where the job is at, where the workload's at. We have a system called EOS, which actually stands for the Eye of Sauron. That's our real-time observation system, and a service layer that lets us manage the workloads. Again, just calling out the open technology that we're leveraging. HTCondor is open. We're using Postgres and Greenplum databases. We have Influx and Kubernetes and Grafana, all these key technologies that Redis and Kafka to support our system, and that's really been a huge boon to us to actually be able to leverage open technology like this. And then, of course, a big open one, Moonray, which we talked about last year, and is now open source, so we can add that to our list of open technology that we're using. Just a quick look at some of the tooling we've developed, dashboards and whatnot. This is our real-time view of what's happening on the farm. So this is monitoring all the processes of Condor itself, and lets us see the job scheduling rate, the latency of the data, throughput, if we're hitting spikes in job errors or any kind of stats that would kind of give the overall health of how the jobs on the farm are progressing. It has additional details on like license count usage, so we can actually see if we're hitting license peaks or license limits and jobs are failing or not getting scheduled because we need more licenses. That is all happens on these dashboards. This is the it's basically Kafka into InfluxDB into Grafana, and this has been a huge help for us as well. And the people are creating new dashboards all the time in this platform, so it's really useful. Moving on to we have a farm manager. This is actually the application that the artists and the resource administrators use to manage the farm. We have a page that shows all the submissions and the progress, and it's very bespoke implementation for our animation business and animators. So showing progress of submissions and where what each show is using at the moment in their resources, and so the artists will use this all the time to see where their job is at. We have built into that a variety of flagging, so these are all submissions that have been flagged as having a problem. So jobs that are exceeding memory or running out of bounds or some other thing that needs investigation. When you're dealing with massive workloads, you need some way to bubble up to the top the thing that needs the most attention, and this tool has really been helpful for that. Looking at data analysis, so the other big aspect of this is looking over the life of a show. So whereas the farm managers, what's happening right now, a show needs to see, okay, what's their trend? How are they consuming the resource? Are they going to exceed the limit for the life of the show, or are they progressing at a rate that they should? Because if they're not, that means either there's work that isn't being done yet, or if they're exceeding it, perhaps there's inefficient assets. If a particular shot, has a teapot that has 1 million vertices instead of 100, that all gets reflected in render consumption. And sometimes you don't see it because there's so much going on. So the tools like this can help them monitor the trends and say, well, that shot is consuming way faster than it should, given what we know about the shot, and then they can investigate and optimize. We have a variety of dashboards like this that are built. The tool we're building these dashboards in, it's not open source, but you can use Power BI if you want to do something like this too. But it's all based on all the data coming out of our Greenplum database, and this has been really key to a show managing the resources. So, with 6 shows in production, it's really important that every show kind of manage their resources carefully. Otherwise, if we exceed the capacity of the studio, then someone's not going to get their work back. Similarly, this actually shows the entire render farm and the breakdown by show and department for those shows. And this report actually gets used heavily by the executives and studio leadership to, so they can go complain to a show that they're exceeding. They're being a farm pig and using too much. Yeah, there's a little bit of shaming that happens. They're like, hey, what are you guys doing? So with that, actually, wrapping up a bit, our system, as described, we can get a queue depth that's like a pending queue. These are jobs that have been submitted that are waiting to get scheduled. Over 100,000. We've actually gotten close to 200,000, but things start to creak a lot when you get that many jobs in the queue. That happens like before holidays, everyone's going on break and they want to get their renders all queued up. So sometimes we'll get a pretty substantial queue depth. And the farm runs 24/7, so if there's stuff to do, it just keeps cranking through it. We do have people that check on it to make sure it's behaving itself. Equally important, we've sustained utilization numbers. So getting numbers of 95% or more utilization, that means all the cores are utilized on the farm, so there's no more room to get work in there. 95 plus is really hard to get to. We don't, in the industry, it's pretty common to see 75, 80% utilization, just given the size and shape of the jobs and trying to get them scheduled. So we're pretty proud that we're able to get that kind of utilization. Our system has been spread across multiple geographical locations. We had a studio in India for a while, and we had one in Northern California and Southern California, which are probably really close to each other from everyone here's perspective, but they're actually kind of far. So we've had those spread out, and that's actually worked really well. We were able to share work between them and monitor the systems effectively. We've done cloud bursting a number of times, and the cloud bursting is, we expect to exceed the capacity of our render farm, so we'll dial up a bunch of resources on a public cloud and have them join our pool and actually be able to schedule work to there. So we've done that a number of times, mostly in a validation test case. We haven't done, we've pushed it to a couple thousand nodes, but as an experiment, we've try not to do that too much because it's expensive. Public clouds is not cheap. And then our current activity, we're spending a lot of time looking at container environments, which we haven't had to do that because our environment is actually we were able to control it. But now, as OSs are moving more quickly and you need to update more frequently because of security concerns and all that, we're finding that a container might be useful in being able to isolate a show because they're in the last 6 weeks and they don't want you to upgrade the OS because it might change the look of their film, and there's a lot of sensitivity around that. So if we can containerize the jobs, we think it should provide better isolation. So a show in the last few weeks of it, we can leave them alone. We can move other people, move the newer shows forward, and avoid some of those hassles. And with that, I think the last one is just more information on Condor. I have a QR code if anyone's curious to find out more about Condor. I keep calling it Condor because it was called Condor for 15 years, and then some Condor company said, hey, you can't use my name, and so now it's HTCondor, so I keep forgetting to call it HTCondor. But it is HTCondor. That's the website, and that's the QR code. And if you guys are looking for a scheduler that's pretty configurable, feel free to check it out. And I think with that, I think that's it. Yep. And if there's any questions?
Hi. I wanted to ask if, like, how much are you able or planning to contribute back, right? Like, Moonray is a huge thing that you do, but like from the list of things that you are using, I'm sure there's things that others could make use of.
Yeah, I mean, it's definitely become more of a priority for DreamWorks, so we're looking at ways to, I mean, even preparing this presentation, I'm like, hey, there's some things in here we could probably give to the Condor folks. So we have, in the years of using Condor, we've definitely contributed back to them and saying, oh, you know, we need the scheduler, would be better for work like this, and they agreed. So we've actually contributed our adjustments there. But it is an increasingly important topic to us. You know, DreamWorks is one of the primary members of the Academy Software Foundation, which some of you may remember from the Friday presentation, and we try to contribute through that channel as much as possible. So, yeah, thank you for anything else? No. All right.
Thank you. Very, very impressive stuff. I have a question about the observability stack you are using, and you mentioned actually the licensing, that you have some threshold about the licensing. Is it? Can you open a little bit more about this?
Well, I mean, a lot of the software running on the farm is licensed, and so it's either per job license or it's per host license. So we have to manage those, and then we monitor their consumption because we want to know if our license is limiting the work too much, then we might need to buy more licenses. But it's mostly just managing the software packages that require a license.
Thanks.
Yeah.
Thank you, Mark. Sorry to upset at least 3 people. You can be caught in the hallway, right? After?
Yeah.
Okay, please remember that. It's great. But we have not 5, not 6. We have 7 lightning talks lined up, so there's no waiting. Thank you, Mark.
Yeah.